In this section we will look closely into hybrid systems in timber, referring specially to the way timber is used alongside other materials. These systems fall outside traditional construction categories and are part of an evolving construction methodology aimed at optimizing material properties and structural performance. It maximizes the strengths and minimizes the weaknesses of each of the materials now working together. Now let's explore the Ferienheim Büttenhardt in Switzerland, completed in 2010. Unlike traditional timber construction that usually employs a uniform type of wood, this design was based on several harvested timbers from the private forest. 4 species of timber were harvested in different quantities: oak, beech, pine and spruce. In this graph you see the division of the different timbers in the design for the building. The inner timber frame and floor structure was constructed in beech. The outer timber frame structure in oak. The other filling in the facades were in pine, and the spruce was used to construct the pitched roof. But there is the kicker. The squared beams underwent core drilling to prevent excessive cracking and twisting while they are drying. This was a crucial engineering solution to make the deciduous logs suitable for construction, which is a true innovation in timber frame construction. The engineers used a special drilling machine that could accommodate 2.60 m long drill bit. This set the maximum beam length at 5.20 m. Steel tie rods were then inserted into these core-drilled oak beams to enable larger column frame spans as well as provide lateral bracing. In the controlled environment of the wood workshop, the timber frame alongside the facade panels were pre-assembled into 2D elements. These elements were then assembled on site to form the outer structural envelope of the building. Timber prefabrication in 2D elements often encompasses the finishing of the facades, which then require no further work to be done on site. In this case, only the window frames were placed later. These innovative techniques were employed given the challenges of sourcing and working with the locally harvested wood, combined with the specific structural requirements of the building and the woodworking skills of the carpenters. The pine boards are cut and sanded. The oak beams are left raw. This renders the facade in a beautiful play of texture and colors. When illuminated by the evening sun, it feels softened and washed in a golden hue. Many timber structures feature a concrete base that comprises the first few floors, transitioning to timber construction for the upper levels. One of the primary reasons for this approach is structural integrity. The concrete base offers strong foundations and can be higher loads, setting a stable stage for the lighter timber structures above. It also keeps the timber structure at a safe distance from the ground conditions. Additionally, the concrete base contributes to fire safety. As a non-combustible material, concrete adds a level of fire resistance to the base. Concrete bases are often more cost-effective for parking garages and commercial spaces. Let's talk about how post and beam structures handle lateral loads. Wind, for example, is a powerful force that can be significantly impact building. In post and beam systems, the horizontal beams resist these lateral forces. But to enhance stability, many structures use what's known as stiff core. Concrete cores are pivotal in timber buildings for enhancing both structural integrity and fire safety. They act as the backbone of the structure, bearing the primary loads and improving the building's overall rigidity. Concrete cores are inherently fire resistant, providing a secure area for evacuation and minimizing fire spread between floors and sections. CLT cores are being explored as an alternative due to their lighter weight and quicker installation process. While still strong, they don't offer the same stiffness as concrete cores, which can be a factor in taller structures. And despite common misconceptions, properly treated CLT can perform well in fire conditions. The outer layer jars, protecting the core and maintaining structural integrity for quite a long period. In general, the lightweight nature of timber is considered an advantage in construction, particularly for topping up existing buildings or constructing on sites with poor soil conditions. However, being too lightweight can pose challenges in certain scenarios. Now, diving deeper into Brock Commons, it's important to note too that this building doesn't strictly adhere to just one category of timber construction system. In most cases, you will find projects sticking to either a post and beam system or a panel and solid timber system. But Brock Commons synthesizes elements of both. In high-rise timber buildings, distributing the load evenly becomes crucial. This often involves transferring loads from timber to other materials like steel or concrete at certain points, making it a true hybrid system. Here is why this is revolutionary. In traditional post and beam construction, the framework is responsible for bearing the vertical loads, while the walls are generally not load-bearing. Brock Commons takes the vertical load-bearing efficiency of the post and beam system using glue-laminated timber for the posts and combines it with the rigidity and lateral stability offered by the concrete cores that are tied together by the solid cross-laminated timber floor panels. This synergy of systems allows for more freedom in design and layout, while also meeting the structural and safety requirements for an 18-story building. This diagram shows the foundation of Brock Commons, the concrete first floors and cores. This base provides stability and houses essential services like elevators and stairwells. Adding to the concrete base, the timber posts combined with the solid timber floor are assembled. This is where the hybrid nature of the building starts to reveal itself. Only 2 floors down, the prefabricated and completely finished facade panels are already mounted between the floor edges. They not only close the building, but also enhance its thermal performance, rounding out the holistic design approach of this hybrid system. We now move on to composite timber concrete floor systems. For instance, composite timber concrete slabs originated in the 1920s. Compared to solely timber structures, these composite slabs offered improved structural performance, fire safety, soundproofing, and they dampen vibrations. They are ideal for medium to long spans. For the composite to work, the concrete acts as the compressive zone while timber serves as the tensile zone. A rigid, shear-resistant connection is essential. These slabs work best as single span beams. Now let's compare the weight and thickness for two different ceiling solutions with a 5 meter span and 43 decibel of impact sound insulation. First, we have the timber solution. It includes a CLT slab, filler for sound insulation, and a finishing layer with a total weight and thickness of 410 millimeters and 400 kilogram per square meter. Next, the timber concrete composite solution. This one is composed of a thinner CLT slab. Combined with the concrete slab, it gets the necessary acoustic qualities. And again, the finishing, if we compare the two, we can see how the timber concrete composite is 100 millimeter thinner while weighing the same as the timber solution. Moving on, let's talk about bonding agents. These agents serve to connect timber and concrete together. We commonly use carves, screws, or glued in sheets. The structural integrity of these panels relies on these specialized joining techniques. There are also different types of cross sections for these composite slabs. Options range from a board stack, board plywood, glulam laying to a beam. Here is an axonometric diagram of a timber concrete composite ceiling with in situ concrete. The first way to manufacture this floor system is in situ concrete on top of a prefabricated timber element. Take note of the construction process showing how concrete is poured in situ. Our next example showcases a plate beam ceiling. The construction involves both prefabrication of wood parts and in situ concrete work. Here you see a linear floor element in the factory. The carves are visible in the bottom part. This element and many more will be transported to the construction site to be assembled on the support structure. Then the floor is ready for in situ casting to become a composite timber concrete floor. Openings for vertical penetrations for building services are included. A layer of concrete is poured on site with reinforcement to prevent cracking. Now let's look at a prefabricated timber concrete composite ceiling. The prefabricated elements are placed using a crane, and the placed elements only require the joints to be poured on site for a largely dry construction process, which keeps the building site very clean. This is another variant of a prefabricated ceiling using plate and beam system instead of mass timber. Here you can witness a large prefabricated element of this type being craned into position. And lastly, we have a unique approach where prefabricated timber concrete composite slabs are bonded with timber beams through screws on the construction site. First, let's look at the timber beam structure. This is the foundation on which the prefabricated timber concrete composite slabs will be attached. Here we see the transportation process. The prefabricated timber concrete composite slabs are being moved on a truck to the construction site. And now we reached the assembly phase. This image captures construction workers screwing the beam structure and timber concrete composite slabs together. This is the moment where both elements come together to create a strong, integrated system. The combination of timber with other materials allows for more versatile design options, enabling architects to optimize each material properties for specific structural or aesthetic needs.